looking building that is going up fast. I think a lot of people saying, gee, what is that? It's precast.
And they're all amazed as they drive past the building, not just how quickly it's going up, but to actually see the finished product, what the actual look of the building is going to be as it's going up, starting at one end and just slowly moving out.
Much quicker than conventional construction. It allows subcontractors to get in and do their work and remain on schedule. It's a great way to do construction.
One of our divisions, research for the research group, is in dire need of square footage. We've got a lot of research going on. We are hiring new people. We've been expanding in the 5 years that I've been here, and in the last 12-18 months we've really gotten an increase in the need of square footage. We've looked at several different options. We found that the best way is to build our own new facility.
The owners desired to go with a total precast structure, which we are familiar with, having done a limited amount of precast work in the past, this being a little different in that the entire building is precast. But there were schedule concerns, the tenant needed to move in by a specific date, and budgetary concerns, obviously, as any project of this size has. And they asked us for our expertise all through the process.
We were able to get the design process done very quickly for the precast that allowed the precast to get started on the forms and making the pieces, and then allowed us, as soon as it was firm enough outside after winter, to be able to go ahead, and they were ready then for the erection process, which has gone much smoother than we even anticipated. So say the building has lent itself to, other than because it is predominantly the precast type construction, we know what the load bearing walls are, and there are many of them, so it really allowed a much greater flexibility overall in the building to make simple changes on some of the walls and so forth, because there wasn't the normal structural impediments.
One of the other beauties of the all precast structure is that it is semi-modular in nature. That is, the erector is coming in and setting 2 and 3 floors at a time in a column grid configuration, so that as the erector moves out of a specific area, we can immediately put a subcontractor or another trade in the area that he's just completed while he's moving down the column line in the grid in the building. So long before the building is completed, we have metal studs going up, we have rough-in electric going in, rough-in HVAC, and all those items that typically had to wait until the framers were out of the way, and generally a framer would do an entire floor, then he'd move up and do the ceiling, then he'd move up and do the roof. This building is going together, first floor, second floor, third floor, roof, and then moving on to each section. It makes it much quicker than conventional construction. It allows subcontractors to get in and do their work and remain on schedule. It's a great way to do construction.
Well, the way that the developers have laid this thing out, we've got it basically in 4 phases, and obviously you can't do the first floor, then the second floor, then the third floor. You have to start from the total component all the way up to the roof, and then work from, let's say, left to right. They grouted the roof decks and poured second floor, third floor decks several weeks back, and the phase 3, phase 4, they hadn't even started on. Foundations were in, and that was it. The other thing with the precast that was eliminated a whole step was we put the footings in, but the foundation walls, which you usually come back and reform it, and it takes more time, there weren't any. The precast is the foundation. In fact, I had somebody call me up saying, a friend of theirs worked at another building, and they said, you got a problem. I said, what's that? He says, they're putting the precast on without foundations. I kind of thought for a minute. I said, what do you mean? He says, well, there's no foundations on it. And I said, go back and tell your friend we don't need foundations. They are the foundations they're setting. They're putting on a spread footing that was designed for the massive loads that the precast took.
Principally, it's more cost effective in this size application. The building's about 120,000 square feet. And from a cost effectiveness standpoint, the exterior of the building is complete when these precast panels go up. So there's no scaffolding of the building, there's no multiple trades working outside and climbing over top of each other.
It really does seem like a very well choreographed process. Not just the erectors themselves and putting together the walls and so forth, but how quickly people could follow along behind and do all the finishing on it, getting planks in place, and then immediately getting floors poured.
We're looking at this is going to be a very energy efficient building, which is another important thing. It can go into a LEED certified building. The materials that we're using are all natural. We're trying to help the environment at the same time, and precast was a big item with that. It is more environmentally friendly compared to certain building products. You know, somebody says, well, why don't you just use vinyl siding? Well, vinyl siding is probably the worst thing you can use on a house or anything, and I wouldn't say you'd use that for something of this size, but you'd be surprised what people use, you know, for certain types of materials. So everything that we're trying to use on this building, inside and outside, are reusable.
Penn State University has adopted a policy that all buildings will be LEED certified by the Green Building Council. Looking at future energy costs, we definitely want to take advantage of a lot of the normal design procedures that go into energy savings. So this building, and a precast building, certainly lends itself to a lot of the things you would normally want to have in place to cut down on energy needs. So very well insulated. A lot of the materials are local materials. There's not a lot of recycling required from waste of material. But to see the net shape, net look in this type of a building is very impressive because of what they were able to produce in terms of making it look like there's limestone at the bottom, all the brick that went into it. I mean, it is real brick, just thinner, and we're not going to have nearly the maintenance issues that you would normally have with brick. We have never had any question from a structural standpoint that this building was going to satisfy all needs, and we have some very specific needs that have additional loads than you would normally find in an office or laboratory type building.
I think design professionals tend to look at total precast structures as they did in the past before modern technologies came into play. For instance, the things you can do with the exterior of the building. The architects want the building to be pleasing on the outside, and before now it was difficult to accomplish that with a precast structure. They would simply make a mold, pour the concrete, and the precast would be kind of this plain panel that just set up and looked rather plain and institutional. With the advances in terms of liners and the forms and the ability to put face brick and integrate architectural details, I think if they had the experience and learned the ins and outs, they'd become proponents as quickly as I have. It's faster, it's more cost effective, it's well insulated, gives you an architecturally pleasing building. The end product is time and budget sensitive, and I'm a huge fan.